Alrighty, so welcome to the June 2023 Regents Review. I'm doing this Regents Review in light of the fact that we did units 1, 2, and 3. Um, and if you did some of 3 and not all of 3, it's okay, we're going to go through, but this is like a good review. So we're going to start out with something calm. So if you take a look at this, number 1 is, if you take a look at the question, it says average rate of change. As soon as you see those words, you should remember y2 minus y1 over x2 minus x1. That's our formula. So they want to know, where is this the greatest? Um, right? So let's go ahead and underline that. So what we have to do is we have to do average rate of change, which is this formula 4 times. Okay. So what do I mean by that? We have our x1, x2. So those are our x's. So we're looking from 1850 to 1910. So let's go ahead and figure this out. So here's our x1, here's our x2. Therefore, this is our y1 and our y2. So we're going to go 29,860 minus, right, our y1 is 629, divided by our x2 is 1910, minus our x1 is 1850. And you're going to find your average rate of change by plugging that into the calculator. So alpha y equals, to get a fraction bar in the calculator, I'm just going to do one with you. Alpha y equals option number 1, and then you're going to put in exactly what you wrote down, 29,860 minus 629, and then on the bottom you're going to plug in 1910 minus 1850, and we hit enter. So we don't want it like this. We want our answer as either a number, right, like a whole number. So I'm going to go ahead and hit my mode, and actually, let me just figure this out real quick. Oh yeah, math, and then let's change that to a decimal, option number 2. So when I hit enter, I get that this is about 487. I could put like a little squiggly line here. So this is about 487. So I would write a 487 right here next to this. And then you're going to do the same thing for each of the other ones, right? So here's our x1, here's our x2. So now we're looking at 1970, right? So here's our x1, y1, minus 1950, which is right here. And this is our x2, y2, and you're going to do the same thing, right? y2 minus y1, so 132,459 minus our y1, 251,808, all over our x2, 1950 minus 1970, plug that into a calculator, hit enter. And you should, for the second one, I'm sorry, that's the third one, my bad. For the third one, you should get that this number is about 5967. So this is about 5967. So let's write that down next to that. And then you do the same thing for each of the other ones. For the second one, you should get 14,805 as your answer. And for number 4, you should get 2,965, and we look to see which one is the greatest. So the one that's in the 14,000s is the greatest. Okay, that wasn't difficult, it was just long and tedious. Okay, oh well. So now you're going to do number 2, which one is not equivalent to. So we did this a lot on the last Regents. um, the easiest way to do this problem, because to get the y by itself, it might be really annoying. And to plug this in, if I were to plug this under y1, and I can't plug it in under y2 because I have a y here and a y here. So that would deter me from plugging that into y1 and y2. But I can use the store button, right? So for x, I usually store 2.1 into x. And for y, 5.4 gets stored into y. So let me just go through how to store again. So 2.1, hit store, it's above the on button, and then you're going to put X, hit enter. So now 2.1 is my X, and 5.4, we're going to store that into Y. To get Y, we hit alpha, and our Y is going to be above the 1, and hit enter. Okay, so now our X is 2.1 and our Y is 5.4. So I'm going to plug in my original, right, which is that right there. So 36 36, x to the sixth, go to the right, minus 25y, so alpha 1 to the fourth, and I'm going to hit enter, and I get this number. So this is our magic number, right? Negative 18, what is it? 18,170. And then I'm going to plug in each of the other answers and see uh, which one gives me 18, negative 18,170, and then see which one is not, keyword is not equal. And you'll see that this one right here, number 3, gives you a different answer. Everything else gives you that negative 18,170. So just to prove it to you, right, parentheses 6x to the sixth, and again, you have to plug it in exactly as is, minus 5y, so alpha 1 to the fourth, go to the right, close those parentheses, open them up again, 6x to the sixth, and plus 5y to the fourth. And again, please plug it in exactly as you see it, hit enter, and you'll see it does not give you exactly the same thing, right? So that's how you know that this is not equivalent. All right. So number 3, what are the zeros? So what you do here is you go to your y equals, and you're going to plug in this whole function. Don't try to graph it. Don't try to figure it out algebraically. It will take you a while. So x to the fourth minus 9x squared plus 3x to the third. So you got to be careful with that. Okay. Minus 27x minus 10x squared. And you could combine like terms here, but in my opinion, why? Do you need to? Because you could just hit graph, and remember what we did last time, right? If you don't see it, you're going to have to change your window. You're going to have to figure out, do we have to zoom out, zoom in? So if I take a look, this is my exponent, is the highest exponent here is a 4. So I should know that it's going to, and the leading coefficient is a positive number. So it's going to look something like that. And if I look at my graph, it does look something like that. So I'm going to hit my window so I can see what's happening below. And I'm going to go to my Y min. And I'm going to change this number to like a negative 30 because I want to see what's happening on the bottom. So there, okay, so that's not enough because I have to go lower than that. Okay, I can see what's happening on this side. So again, all I'm doing is I'm looking for the zeros. So I could right now at this time stop and I can go because I have my 4 zeros there. And so the highest exponent tells me where the zeros are at. So boom, I have 2, I have 3. So answers are going to be 2 comma 3. And then let's see where my other zeros are. So I'm going to scroll up. There's another one, negative 3. And let's see if we can find one more so we don't have, okay, perfect, negative 5. So here's our answers, right? Negative 5, negative 3, 2, and 3, which is exactly what choice 4 says, okay? For now, I'm going to skip number 4. For question number 5, the range of temperatures, right? So if I look over here, so my x is my domain, remember this from Algebra 1, and my y is my range. So what I have to do is I have to put in this is a 12-month period, you have a function here. So we're looking to see what numbers are my output, my range, right? So if I take a look at this, so the easiest way to do this is to go ahead to your graphing calculator, go to y equals, erase what was there. Since we have pi over 6, we're going to keep our mode in radians. 90% of the time, your mode can be in radians, but I'll tell you when we have to go through degrees. But anyway, so again, plug it in, and then I'm going to hit graph just to kind of see what my range is going to be. So automatically right now I can see that there's no negative numbers, right? Like, because I don't see anything here. So anything that has a negative number actually can go away at this point. But let's just say I didn't know that, right? If I hit my window and I change my Y max right here, let's just be dramatic about it and go 100. And now let's see if I graph it. Okay, so now I see something. So my range again is my Y, right? So what numbers can my Y be? So it looks like it's ne again, never it's never going to be negative. So I was right by crossing out anything that had a negative sign. Therefore the answer is 2. But if I couldn't see it like that because there were more than one answer, if I go to my table, okay, I see 79 is my highest number that I have. And if I keep going down, I'm looking for my lowest number. My lowest number is 33. So my range is between 33 and 79, which is again what this answer says, right? From 33 to 79. All right. It says which expression is an equivalent form for number 6 of a fifth root of a to the fourth. So again, this could be a calculator question. So I can go to my calculator here. Um, I think my 2.1 is still, okay, so X is now 10 because I think I reset my calculator, but it's fine. Let me go 2.1, store in for X, hit enter. And so now I'm going to plug this in. So I have X, I'm using X instead of my, um, yeah, X instead of A, that's fine. And then I'm going to do times. You can put the 5 in, hit math, and I'm going to do option number 5 is the fifth root. And then again, I used X instead of A, and I'm going to put it to the fourth power because that's what it says in my question. So my magic number that I'm looking for is 3.80 hamana hamana hamana. And then I already know that this is not the answer. So if I plug in each of the other ones to see which one gives me the answer that is the same, and again, I can do this because of the word is an equivalent form, I'm going to see that choice 2, right? So if I go like this and I do x to the, and I do alpha y equals to get my fraction, and I have 9 over 5, and I hit enter, I get my magic number. Okay, so this is also 3.80. And again, nobody knows if you can do this algebraically or not because um, they're not standing over your shoulder. This is multiple choice. Again, is equivalent to beautiful, right? So technically, there's no X's or there's a A, and the rest of them are I's. So you could store a number in for A. Um, Actually, we could even just use our X because we have X is equal to 2.1 again. So I can go 3. I is second decimal point, right? And then we go parentheses. Instead of my A, I'm going to substitute it with an X. So I put in X, I, so second parentheses, second decimal again. And I have minus 6I squared, and then I'm going to close parentheses. And then I'm going to, so this, my magic number is negative 6.3 plus, what was it, 18I. And I'm looking for the one that is the same as it when I plug it in. And option number 3 is. So try each of the other ones. You're going to see it's not equal. The one that is equal is negative 3A plus 18I. All right. Which equation best represents the graph below? So this is straight calculator question. So I would pick numbers for A, negative A, and A. So let's just say I look at this. This looks like negative 2, and this is 2. So A is equal to 2. Okay. And then if I were to say C right here, to make it a little bit different, I could say that C is 3. And again, all I'm doing is I'm picking numbers for A and C. And then I'm going to go ahead and take my calculator and see which one matches with that. So if I go to my y equals, let's clear what's there. And I'm going to go ahead and just plug in each of them that are there. So I have log, which is right above the ln button, is log, because I don't have a base. and I put x plus, my a is 2, so I'm going to put a 2 down. I'm going to close those parentheses, put plus c is 3, so I'm going to put 3 here, and then I'm going to hit graph. And then I want to see if that matches what we have. So my window's kind of off, so let me hit zoom. Option number 6 is standard, so I can see if it matches it better. Um, and I want to see if this does. So let's see. If I go to my table, so second graph, across from -1, I see 3. Okay, so this, if this is -2, then this is -1. So -1 and my C here is 3, so that does work. Looks like my answer, like I'm done. Let me check that again. So opposite 2 is 3.6. So here's 2, and could this be 3.6? Sure. So my answer that matches is option number 1. And again, all I did is I picked numbers in for A and C, and then I'm matching to see which one is the same thing. Okay. Question number 9. So this means as x goes to the negative infinity, right? So x is left or right. If I'm talking about negative infinity, I'm talking about the direction of left. So as x goes to the left, f of x, which is y, goes to, right? Does it go up or down? So it actually, so it might seem like there's been a time continuum jump or bump. That's because I had to run to the bathroom. But anyway, I'm back. So f of x is y. So I already said that. And where does y go, right? Y goes either up or down. This is our y. So if it's going to negative infinity, then it is going down. Down. Okay. So what we're going to do is we're going to take a look at each of them and see which one has that. So as we go left, y is going down. As we go left, what's happening to our y here? Isn't it going up? So it's not that. As we go left, our y is again going up, so it's not number 2, which means that I have to graph the other ones, right? So I'm going to go to my calculator here, go to my y equals, type in 5 parentheses 4, right? Close parentheses to the negative x, and I'm going to go ahead and hit graph. And so I'm going to take a look at the graph that I get and see if when I'm going to the left, my graph goes down. And that's also not true, right? As I go to the left, my graph is actually going up, right? You can see that right here. So I go to the left, my graph is going up. So that is not it. So by default, this has to be. And when you plug it, you will see. I should just do this. I should stop being lazy. So this one, let me clear this. So I have a negative sign. I'm going to do log base 5. So I have to hit math, go down to the bottom to log base, put the 5 there, go inside the parentheses and put negative x. And then I'm going to graph it. Oh, 2. What did I do wrong? I didn't put the 5 in. Okay. And now when I hit graph, there we go. Okay, so we can see it, right? As I go to the left, let me go ahead and put this over here so you can see it. As we go to the left, right, our graph is going down. That's exactly what's happening. So our answer is choice number 4. All right. All right, here's another is equivalent to. I think we've done this enough. So this is literally just plugging it into the calculator. You could plug this under y1, plug each of the other ones under y2, and see which one matches. When you do that, you will see that the first one does not match. The answer is going to be the second one. Or that you could do, if you don't know the y1, y2, what I mean by that is you go here, type in the expression itself, which is this whole thing, and then you go to y2 and type this, and then go to the table and see if your x and your y1 and y2, if these are exactly the same. Okay, that's how you check and see if they are equivalent. or you can use the store button, right? Store a number in for X, press enter. This is similar to what we did before, and then see which one gives you the same answer, and that is also going to be 2. All right, so this next one right here, this is straight calculator. So if you forgot how to do this, you hit the apps button, which is next to math. On your calculator, it might be 8 or 9. We're looking for polysimult 2. And then here it says press any key. We're going to press option number 2, which is simultaneous equation solver. So there are 3 equations here. So I'm going to go over to 3, hit enter, go down. There are 3 unknowns here, x, y, and z. I leave my answer as a fraction, that's fine. Press graph to hit next, and now I'm plugging in the numbers that are in front of my x. So here there's a 1, 1, 1, and then a 2. So I go to my calculator and type that in. 1, 1, 1, 2. Don't forget to hit enter after each one. For the next one, I have 1, negative 2, negative 1, and negative 4. So let me go to my calculator and do that. 1, negative 2, right? Enter, negative 1, enter, negative 4, enter. And then I have 1, enter, negative 9, enter, 1, enter, and negative 18. Enter. Don't forget to hit enter after that last one. And then you're going to hit graph again. And it gives you 0, 2, 0. Boom, right here. Option number 3, 0, 2, 0. The roots are. So again, you could take this and you could plug this into the calculator, except this has an I in it. So the best way to do this, if you take your calculator here, is to use the store button. So let me show you what I mean by that. Let me quit out of this. So press number 6. Right? So I'm going to give you an example of what I mean. So for the first one, 2 plus 3i. So I'm going to go to my calculator. 2 plus 3i, second dot. I'm going to hit store, and I'm storing this in for x. Hit enter. Okay? Now I'm going to plug in x squared minus 4x. And if I get negative 13, that's my answer. So x squared minus 4x. Hit enter. Okay, I get negative 13. So it looks like that is my answer. If I were to plug in anything else, like if I were to go up here, and instead of 2 plus 3i, I plugged in, you see how answer choice number 2 is 2 plus 6i. So if I go over here and change that 3i to a 6i and hit enter, and then go up and grab that x squared minus 4x, it should not give me negative 13. There you go, right? If I do the same thing with this one right here, 2 plus radical 17, I store that in for x. I plug this answer in, I will not get negative 13, and if I do the last one, that will also not work, okay? All right, which expression is equivalent to? Again, is equivalent to, which means that we can use either y1, right? Plug that under y1, plug each of the other ones under y2, and see which one gives you the same table for your y1 and your y2, which one gives you the same answers. That's one way to do it, or you can use the store button. So yeah, either way you do it, you get that the answer for this one is going to be number 1. Okay, simple, straightforward, to the point. And again, please do this. So exponential regression, we did do this on Delta Math. So you hit the stat button, which is under delete, go to option number 1, which is edit, and plug in your numbers, okay? So the top numbers are L1, the bottom numbers are L2. So through the magic of computers and technology, I'm able to go ahead and plug that in pretty quickly. And then you hit stat, go over to calc. And since we're looking for exponential regression, we're looking for the one that says xreg, which is option 0. Hit enter, and then you're literally just hitting enter a bunch of times. Okay, good. And it gives you your equation, right? So you have y equals, what does it say, 1.77. So I'm just rounding, and then we're going to have parentheses here. This is going to be, the b is going to be 1.18 to the x power. And it says about how many followers did she have on June 1st, 2018. So if we take a look at the number of months since January 2015, how far away is June 1st, 2018, right? So that's 3 years and 6 months. So that is going to be where x is equal to 41, right? So we take 41 and we plug it in for x. So you're really plugging into the calculator 1.77 times 1.18 to the 41st power. You don't need to do the y equals. And when you hit enter, you're going to get about 1,850,000. Okay. It's going to be, I think 950 is the rest of it. All right. So it says which function can best be approximated by. This is also something that you can plug into your y1, y2, and match. And again, we're getting to the one that is the closest. So our I0 is just our initial. All of them have I0, so I can just ignore that and ignore that. So what am I plugging in? I'm going to my calculator and I'm clearing what's there. So I'm plugging in e to the, so e is second ln, and I'm going to plug in 3. I said 3, and then parentheses, and we're going to do a fraction. And so again, I'm not plugging in the I0 because that's my initial. That can be, in my eyes, it's just 1. So I just cancel them out. And then I plugged in the first answer choice, which is, I'm sorry, the second answer choice, which is e to the 5x. I didn't plug in the first one just because I wanted to show you. And so now I'm going to go to my table and I'm looking for numbers that are pretty close together. So if you look across from 1, do you see what I see? It says 0.00 something, and then on the Y2 it says 148. So they're not close to each other. So I know it's not going to be that one. And you keep doing that. So if I plug in the third one, I didn't plug in the first one because it has a fraction, but you could. So again, I want to leave my original there, and I'm going to, this doesn't have an E in it, so I'm going to clear this and put parentheses 0.0067, close parentheses, to the, instead of X, I'm sorry, instead of the T, I'm going to put X, and I'm going to go to second graph. And if I look at these numbers are pretty close together, right? So if I look from across from 0, there's a 1, 1, which the other one had, but look at the one that is across from, right, across from 1, you see this? It says 0.00674, and then on the right is 0.0067. So that is pretty close to each other. So I'm going to stop right there and say that 3 is the one that is approximate. Okay, we didn't do 16, so let's go ahead and skip that. Did we do 16? Actually, we did. We did do this. I'm not going to skip that. Take that back. All right, so on the practice regions that we had, this is how you do this question. Ready? Ready? So let's quit this. So for those of you who are in Algebra 2 who just did Unit 1, 2, and 3, this is something that we're going to just learn for the first time. Those of you who are in IB Math, this is going to be something that we've done in the practice regions, the 2 previous. So we're going to hit second vars. We're going to scroll down and we're going to get to the one that says binom CDF. My bad. It is the one, let's go back. It's normal CDF. So we're going to go to this one right here. So it says less than 60 inches or greater than 65 inches would have a height. So it is not going to be between 60 and 75. So, okay, fine. Let's skip that. In light of the fact that my Algebra 2 students have not done that yet. This one we haven't done, so let's skip that. This one right here, even and odd, we did do this, okay? We did do even and odd functions. So even functions, remember, is symmetrical with respect to the y-axis, which means that if I take my function and I flip it over the y-axis, it's going to look the same. So that is an even function. If I have something that looks like that, that's an even function. Something that looks like that is an even function. Okay. Odd functions are something that looks like, ooh, something that looks like this. Whereas if I were to take my function and turn my paper around 180 degrees, it's going to look exactly the same. When I go to the right, it's going to go up, bottom to the left, it's going to go down. So that's what an odd function is, okay? It looks the same when I turn it around 180 degrees. So even and odd. All right, so now this is just a matter of plugging this into my calculator. So I'm looking to see which ones are even, which ones are odd. So I go to my calculator here, go to my y equals, erase what's there, erase what's here. So it says 2f of x and f2x are even functions. So let's go ahead and see what that means. 2f of x. So f of x says cosine of x. So I'm going to go here and put 2 f of x, which is cosine of x, and close my parentheses. And I'm going to hit graph. And I'm going to see, is this an even function? Which means that if I take it and I cut it where the y-axis is it going to look the same on the left and right? And it is, right? If I take it, cut it along the y-axis, the left side is going to equal the right side, right? So it looks something like this, this, that looks the same. So this one is an even function. Good. So now I want to see if f of 2x. So I'm going to go back here, and under y2, I'm going to do cosine of 2x. Okay, close those parentheses, hit graph. This is my red one. Is my red function also an even function? And boom, it is. Okay, because if I take this function, let me just show you what I mean. If I take my function and I split it right where the y-axis is, it looks exactly the same on the left and the right. So both of them are even functions, so I can actually stop right there and I'm done. Solution set, I'm going to go y1 here, y2 here, see where they intersect. So I went ahead and plugged it into y1 and y2, and I'm going to hit graph. So the first graph is going to look a little crazy, but it's going to look like that. The second graph is right here, so they meet once. Looks like maybe 2 times. Okay, so there's, yeah, it looks like it meets 2 times. So let's see where they meet. Okay, so if I look at my answer choices, I have -6, 5, 5, -6. So let me go to my table, and I'm looking at the numbers that I have. So 5 is error for both of them. So that's not going to work because they are not exactly the same. Not all errors are the same. Across from 6, I don't have the same set of numbers. So it's not 5 or 6. So anything that has a 5 in it or a 6 in it, I can get rid of. So the only one that is left is -6. And let me check that, okay? If I go hit, I want to be lazy. Second window, I want to start it at -6. Second graph, and boom, across from -6, I see -27 over 22, and across from y1, I'm sorry, y2, I also see -27 over 22. That is the same answer, so therefore my answer choice is -6. Okay, again, is equivalent to, so this is the store button. I think we've done this enough, so you could go ahead and plug this in and see which answer is the same. Please see me if you don't get this, but what we will see is all of them are equivalent to x to the third over y. And again, store numbers, right? I usually use 2.1 for x and 5.4 for my y. You can use whatever you want. Just don't use 0, 1, or 2. Do not use those numbers. But anything else you can store in and see that all of them are the same. Inverse, okay? We did this. This is our last lesson. So inverse is, we have y equals 2/3 x plus 1/6. We're going to take x and y and switch it. So that's going to become x equals 2/3 y plus 6. I'm going to stop and look. None of them have x equals, so I can't stop there. I have to get the y by itself, subtract 6 from both sides. This cancels out. X minus 6 equals 2/3 y. And then I have to get rid of the 2/3 by multiplying by the flip, 3/2. So I have to multiply this side by 3/2 as well. That allows us to cancel this. So I have y on the right. 3/2 times x is 3/2 x. So automatically this is out, this is out. So it's between 3 and 4. And 3/2 times -6, I can do this into my calculator, hit enter, and I get -1/4 as my answer, which is choice 3. Okay, done. How many equations below are identities? And again, this is a store button question. Store numbers in, plug in, get an answer for this. Is it the same thing as the answer for this? And you will see that none of them are the same, right? So none of, like if you store a number, it's going to be different than this number. So none of them are the same. Focus and directrix, we did do this, so I'm going to hold you accountable for this. So focus is 0, 6. So 1, 2, 3, 4, 5, 6. I'm estimating this. And the directrix is y equals 4. So 1, 2, 3, 4 is my directrix. So what I do to find the vertex is I look for the point in the middle, which is this point right here at 0, comma 5. So here's my h, here's my k. My p is this distance right here, which is 1. And then I have to see if my parabola opens up or down. It can never cross the directrix. I'm going to do what is wrong. It can never cross this line right here. So I have to take that out, and let's take that out. So what does that mean? That means that my parabola is going to open up. It's going to open up like this. So that means my p is going to be positive. So what is my formula, right? So my formula is right here. This needs to be memorized, so it should go in your cheat sheet. So I have y equals 1/4p. P in this case is 1. So I do x minus my h, which is 0, squared plus k, which is 5. And then I simplify this. So I get y equals 1/4. X minus 0, anything minus 0 is just itself. So that's going to be x squared plus 5. And then I have to see which one is the same as that. And so let's see. So this one gets the y squared. So the y squareds are wrong, right? The only thing that's getting squared here is my x. So if I subtract 5 from both sides, this cancels out. Y minus 5 is equal to 1/4 x squared. And again, to get rid of the 1/4, I multiply by the flip, which is just 4, which means I multiplied this by the flip. So this cancels, and I get x squared is equal to 4 parentheses y minus 5, which is exactly what 2 says. Okay. All right, we're almost done with the multiple choice. Woo-wee! How many minutes in are we? Okay, not bad. Um, yeah, we didn't do this before, but this is in our formula booklet. So let me just pause real quick and show you. So if you look at the last page of your booklet, there's a formula booklet, and there's a formula that looks like this. A1 minus A1R to the N all over 1 minus R. So we're going to use that formula. And this is the last question, so if you don't get this completely correct, it's fine. So the account pays 4% interest. So 4% gets added to my 100%. So that's equal to 104%, which as a decimal is 1.04. So that's the first thing with that. The $500 is deposited. That's how much we start with. That's what our A1 is. The last is going to be the 21st. Okay. So let me just go ahead and write our formula. So A1 minus A1, okay, times R to the N. So I'm going to go ahead and plug numbers in. So I'm starting with $500 is the deposit. So I'm going to go 500 minus A1 again, which is 500. My R is 1.04 to the N, which is 21st, because we are stopping at the child's 21st birthday. And then on the bottom is 1 minus our R, which is 1.04. So we're looking to see which one is the same as this. Doesn't look like 1 or 3. Um, the difference between 2 and 4 are that they use the wrong rate here. So that's out. So the only answer that makes sense is 2. Okay. I'm going to stop it. This is our part 1 for the June 2023 Regents based off of units 1 through 3. There'll be another video for part 2.